Right, in this lecture, we're going to look at AWS IoT, and I have introduced you to AWS IoT previously about what this is about. And we're going to look a little more details, how are you going to use this IoT to help in our IoT projects. Now, in this particular lecture, we're going to actually look at the very, the basic elements of using the IoT, and we're going to actually build upon this in the a couple of lectures later. So first of all, let's take a quick look at the IoT components at AWS, what AWS offers specifically. And this is a so-called architecture diagram. There's basically three tiers here, and you'll see that this kind of reflects with our a basic IoT system architecture that we talk about previously. You've got the sort of the device layer, and they have a control layer, and they have a analysis layer. And these are the core elements of IoT system. So you'll notice that AWS IoT provides services for each layer when we build IoT system. So at the device layer, what the AWS offers is, first of all, it's got a real-time operating system. There's a free RTOS is meant for low capacity, real-time situation for microcontrollers, and not exactly for Raspberry Pi. Raspberry Pi it's a mini computer. It's more of a general purpose computer than a microcontroller. It's more powerful than a typical microcontroller. So it's a device that we use to experiment with IoT projects, and it's pretty versatile. It's more capable, so you can do a lot of stuff. Now, when you actually deploy a IoT system, you have a couple of things that you want to do with sort of a more of a simpler scenario. And actually, you may also have in a particular case where you have a more of a real-time consideration that then you may consider using the free RTOS, or there's other alternatives. But if you're going with AWS, and this free RTOS, by the way, is a open source project, so you can actually run that. There's a huge list of microcontrollers that's supported by free RTOS. So we are not really using this here. This is obviously also Linux-based operating system. I'm sorry, I take that back. It's not necessarily Linux-based, but it's similar to Linux, but it's more real-time feature. And what real-time is that it gives you a guarantee on executing your program in terms of timing. So that's the free RTOS. And then it offers the SDKs for your devices. Now the SDK is software development kits. This SDK is really sort of like the language bindings. It's all got the sort of a your functions or classes in your particular language. It's the language bindings for communicating with the AWS IoT services. It supports pretty much most of the popular languages, including Python. So it makes it a little easier for you to program. Now, there's pros and cons of using the SDKs, but AWS, from their perspective, they want you to build your program on AWS. They want you to be so-called locked in to their ecosystem. So it depends on what you're building. whether you want your program to be so say more or less generic that you can actually run on AWS or run on Azure or or Google Cloud. That's if that's a consideration. And then you may have to think about how you're going to build your application that will be able to, that's sort of portable on different systems. And so in our demonstration, we are in this particular example, in this lecture, we're not going to use the SDK. We are, as you'll see, we're going to use the things that we've used before. You don't have to use it, but there's also an advantage of using this as well. AWS try to be compatible with the regular popular standards that's out there, but it also tries to make enhancements to differentiate itself from other vendors. So anyway, the SDKs, it's basically how you build your software with these ready-made libraries to communicate with the IoT services. Now, you got the device tester. The device tester helps you to test your program. For example, the MQTT-based communication, just to verify that it is working, and you can use that to test. Then you can also use this tester to test whether your device is running your FreeRTOS properly. Again, this is just another tool that they provide. The green grass is it's a piece of software that you can run on the device that I would say, on a device such as, Raspberry Pi or somewhat, commodity computer that you use at the edge, basically closer to where your physical devices are deployed in more of a gateway device. And then you run this green grass that will help you to build applications that will process data locally before you send information to the cloud, instead of processing everything on the cloud. So this is the idea of fog computing that remember that I introduced last time, that you want to do as much computation locally as possible so that you can reduce the cost of the bandwidth, shipping all this data to the cloud and then do the processing in the cloud. So it's relatively cheaper to do your processing locally, including machine learning and some of the analysis you can even do locally. So Greengrass is a service that allows you to run some of those things locally. And then there's also performance consideration there as well. Now, this is a device layer that they give the physical layer, the AWS provides you those things. And the controller layer that it provides the device management. Now, why? Well, in our particular simple examples, we're dealing with a single device, basically. We don't really have to worry about device management as much. But this becomes important if you have hundreds or even thousands of devices deployed around in your scenario. Let's say you have a huge commercial building, you have lots of devices deployed, cameras, sensors, in a production line, or in a farm, you have lots of sensors deployed, let's say in a vineyard, monitoring the health of the plants, right? There's all kinds of scenario where you're going to have a ton of those devices, not just really one in our experimental, in our particular simple case. So in that case where you want to use device management, can you build your own? Yes, you can build your own. It's not that difficult to build, but the IoT AWS provides those things ready to use. So it helps you get started quickly. Now, the IoT core, really what that comes down to, I have another picture to look into this a little bit further, is the communication hub of the devices. And then also this provides some kind of a rules engine that you will be able to process the data, trigger events and stuff like that. Device Defender, this is really a security piece of software that helps you examine whether your software is running on the devices are up to date, whether there's any vulnerabilities that you need to be aware of, or maybe the certificates are expiring or expired, and then you want to get those fixed. So this is kind of again, what it offers probably will change, evolve over time, but this idea is this is going to give you some security enhancements to your system. It's like an auditor, so to speak. Now you got the things graph. The things graph is it's a graphical, it's a visually, it's a software that is a service that allows you to put together different devices in a drag and drop fashion to help build an application that or a flow that you can communicate. You can actually process your different devices, even though they may be speaking different protocols. That the value of this is that instead of writing your own code, this probably will help you solve some of the integration problems when you got devices that's provided by different vendors, they speak different protocols. And again, this is what that is for. And then at the top layer where you have the analysis, data analysis. So the analysis here, of obviously analytics, this really is just a, you don't really have to use these things because AWS already provides many of the other services that you can use to build out your analytics, the databases, data analytics services that's there. I mean, do you really need IoT specific analytics? Not necessarily, but again, this is AWS tries to package things, in a neat way that makes it a little easier for you to build your applications. Yeah, so if you have a need to use it. Site-wise is basically another analytics software that helps you orchestrate, coordinate the data streams from various different devices in a single building on a site. So, and the events, again, is another abstraction over the events that are coming from the sensors or actuators that you want to somehow process them and trigger events and do certain things like essentially make an API call or make something happen. So it's I would say it's a little bit complicated with all this stuff over here, and I guess there's a value they're trying to provide for every one of those services. But really, when you're building your IoT system, you use what you need. If it depends on your situation. You actually don't even need to use any of this. You can just build your own stuff. But this is just kind of I'm showing you what this AWS offers, and not necessarily we're going to get into all these details in this course. I just kind of give you overview of what they offer. And then the IoT core is something that we're going to experiment in this particular lecture. So the IoT core, if we take a closer look, this green boxes here, you got a message broker, which is really MQTT broker. If you recall, we talk about MQTT is it's a communication protocol or application layer communication protocol for IoT devices. It's designed to be resilient, low power consumption. It's very popular, and it's a bi-directional communication, not just a single direction. Means that both the client and server can communicate with each other. They can initiate messages. So it's a very important component. And then you've got the device shadows. Really, just means these are entities running to represent the states of your devices, and whether the device may be unreliable, they go online and offline unreliably, but the device shadow will give you a sort of a reliable endpoint that represents the latest state of the devices. Then your application can communicate with the device shadows if you want, instead of talking with the actual devices that it could be unreliable. Rules engine, well, you got the things happening in the among the devices, then you want to process something, right? Based on the information you get from the devices, you want to process, you want to take some action in certain situations, then this rules engine will help you to build the things that you want to do. Maybe send a notification, maybe it will trigger something else, to do anything else. So these are really the main components. And then the security identity really is just a built-in part of the services. That's always a consideration. Make sure the transport protocol is secure, such as a TLS, and then the users identified through the AWS identity infrastructure. So, and so the rules engine really, when you build out your rules to take any action based on the inputs from the devices, device shadows, or message brokers that messages are sending out, then what you want to do is then you're going to use some of those AWS services to send notifications or run some program. These are the things that will allow you to do. This is really part of the AWS offering. And then you will build your applications using the SDK. These applications also could be just consuming those services. Basically they are connecting with devices through the rules engine here. Okay, so this is kind of the idea of IoT core. That's the sort of the main piece of these AWS IoT services, or in the control layer, as you see what they offer here. Not all the services are equivalent. I always say the starting point will be the IoT core. This is a little more most valuable piece of this IoT system. Now let's take an example here. Actually, let's just communicate with. Let's start communicating with. Well, let's set up a thing. So in the AWS IoT, your device is called a thing. Each device is a thing. Let's actually use Cloud Shell. The reason we use Cloud Shell is that you don't need to set up your AWS client, the CLI, or figure out the authentication, identity, everything like that. So this Cloud Shell is very convenient. It gives you a Linux terminal that's got most of the things that you need for command lines, ready to go. So we're going to use this as we used before. So instead of creating, last time I gave you a script to run some of the setup because it was a bit of complicated. I wanted to automate that for you, and so that you don't get too much struggle. Now, in this case, I will not offer you a script. I'll basically show you how to execute each command individually. This is pretty straightforward. There's only a few things to do. So I'll show you to directly run the commands. Okay, if this can, all right. Okay, takes a little while. Really what's happening is behind the scene, it kind of spins up an instance or some container on an instance or something like that. Anyway, so we'll have this Cloud Shell here. First thing is we're gonna name our thing. So in my testing already, now when you do this, this is basically where doing the command line, running this in a bash shell. So we're going to define a local environment variable and call it thing name. I'm gonna call this thing 2 because I already tried thing 1. I'm going to use a different name here. So this is the name that we're going to be using here. Okay. And then first thing we want to do is to create a thing that in AWS. Really what's happening is AWS is going to store that piece of information in a database. So what we're going to do is we'll execute this command. Now, this is really the AWS is the AWS CLI, the command line interface. So this is the command line tool that you use to basically do pretty much everything that AWS offers. That has. So for all the API AWS offers, you can use the SDK to do those things in your own program, or they already built a command line tool that you also use the same APIs. Then you can actually just use this to manipulate your resources. And this is very suitable for automation, and you don't have to build your own program. So let's actually create a thing called, I'm using this course identifier and then dash that thing name, which is thing 2. So this gives us a response of the object we created is a thing. The thing is described by a name. It has an ARN, which is really the Amazon resource name. It's called Amazon resource name. Is a unique identifier that you have seen something like this before. It's multiple pieces of information. This whole string identifies your resource uniquely. And Amazon uses the same format to describe pretty much everything in the cloud. And then also it has another randomly generated ID here, okay? Now, if you list out your things right now in your AWS account, now keep in mind though, we're always going to be using the Oregon region here, okay? So these things are going to be staying in one region. If you go to a different region, then you'll have a different data. Okay, so they're not the same. So if you list your things, in my case, I have 2 things here. I have a thing 1 and thing 2. So you will just have a thing 2 here if you're doing this the first time. Now, the next thing we want to do is generate the keys and a certificate, because every device needs to be, when we actually write a program that represents the device, or we run this on the Raspberry Pi, and then that program needs an identity. The identity is basically a certificate, just like your SSH. When you generate SSH key for your computer, so you can access GitHub, you can do, you can allow another computer to connect to you. And this is just basically using the cryptography to create some random string, really, following a certain protocol, and then that uniquely identifies your device. So that device will be identified with some keys and certificates. So we're going to run this command, which is AWS IoT create keys and a certificate command. And then we're going to specify the output file names, because this command will generate these files. These files, you can just generate them with OpenSSL as well, if you, but this is convenient. It's going to generate these things directly and then have that proper setup. And this is really the name we're giving it. It's going to generate 3 files here: a certificate file, a public key, and a private key. So if we're going to run that, okay, so basically you'll see it gives a response. It gives this JSON object here. The certificate is generated, and it has a certificate. This value really is the content of the certificate, and you have the key pair, a public key and a private key. Okay, so that's that. So if I take a look, this actually will have these files generate. Actually, you know what? Let me create a folder, W13. so that we're not getting. We're gonna move this files that we just generated into that W13 folder. Okay. So this is probably better because don't wanna get confused with other things that's already here. So let's go to that W13 folder. So these are the 3 files that we just generated through this command. And then we're gonna need to use these files actually. Actually the cert file, the private key, the public key we don't need to use. And then the other thing we wanna do is to download a root certificate from a URL. So this is, well, do I have the HTTP command here? Did we install this last time? I think we might have. Okay, this is the HTTP. We'll have this installed from last time. So, okay, and then we're gonna download this certificate from AmazonTrust.com. Now, AmazonTrust.com, and if you really take a look, this is the Amazon's own trust CA. Well, repository. So if you take a look at here, this has actually got a bunch of root CAs here. So I'm not gonna get into details about what is a CA, the certificate authority. This is really about cryptography and how really how your, for example, your HTTPS, the TLS, everything is built on this sort of a public key, private key, asymmetric. It's called asymmetric cryptography. There's a lot of research into this, and this is really proven to be secure. And this is what really is used in pretty much everywhere for secure communication. Okay, so we're gonna download this file. So this file is downloaded into the file name is gonna be also Amazon root ca1.pem. This is also here. So we'll have all these files that we're gonna need to use when we actually run the program. Now, next thing is we're going to actually create a policy. This policy determines what kind of actions can be taken in the communication between the device and the broker, the MQTT broker, actually. So first, we're gonna get the account key. This is suitable for automation. I mean, of course, you can find your account key actually right here, right? You can just, oh, okay, here's my account key. Sorry, account ID, right? So every account has a unique ID, is a numerical ID. So this will give you the ID. If you just echo this out, you'll see it's the same, okay? But we're using this AWS CLI to actually get the account ID. So if you run this in your Cloud Shell, you'll get this ID here. So we're going to use this value later on in the commands. Now, next thing we want to do is actually we'll need to. So we have the IoT policy is a JSON document. Now, this JSON document has a couple of things in there. What this does, and now lots of the AWS policies are in this particular format. So you actually have seen this before when we did the introduction to the AWS basics. Did not explain too much about it, but this is really the idea. AWS has this sort of role, sort of action. This is called the permissions. Every resource and action is controlled with some kind of policy. So, for example, this has a couple of policy statements, and then the first statement is to allow these actions. They are tied to the APIs, exactly the API that you can use. For example, to publish a message to the broker and to receive a message from the broker. And then this is saying we can do these actions, take these actions on these resources, and this identifies a resource. Now, actually, with the wildcard here /star. So as you notice here, that this is a particular ARN. Now, towards the end, you see a topic. This is the MQTT. We're talking about MQTT MQTT resources. So you have a topic that a publisher can publish messages to, and the subscribers can subscribe to for messages. So it's the hierarchical structure for the topic and name. So you have topic slash whatever you say is your topic. Let's say our topic is going to be called the CIS-30D-21S slash something, like thing, maybe thing 1, thing 2, your device name, and then go that way. Let's say this is your topic, and you have a more sub topic names if you want, right? So this with a asterisk here, sort of identifies all these resources, and then we're able to actually publish and receive. There's also another special variable here that also is saying, when you communicate with the MQTT, you can specify a client ID or have the system generate a random one for you. But either way, let's say you want to have a topic that's identified prefixed with a client ID, then this also allows you to do. We're not using this one particularly. We're going to just use a named topic for our tests. Now, this one is similarly saying, okay, we can subscribe to these topics as well. And now when you subscribe, what you specify in terms of the resources, a topic filter. A topic filter has a specific format there. Actually, you can subscribe to multiple topics with a single expression. So we are, again, this is similar to that, but it's using the topic filter resource, and we can subscribe to those things. Now, you can also do a connect. We're allowed to connect. We allow the device to connect from whatever client. So they say all clients can connect. This is not necessarily the most secure way. When you actually build your application, you want to be sort of a more specific about this. Well, this is actually fun because you do have other levels of control in terms of the certificates that's in your account that were just created with that command. And so the account knows what certificates and what clients can be authenticated. Maybe not by the client ID, but by the identity of that client, which uses those certificates that we just generated. Okay. So anyway, this is a policy document that sets up the permissions so that you can communicate on MQTT with AWS IoT. All right. So as you'll notice, we actually have, this is sort of like a template. We have some placeholders here with it. And this is just, the percent and a percent. It's basically, you can use it whatever way to, this is made up to, will be replaced with the actual account ID. So how we're going to replace this? So we replace this with the sed command, which is a very versatile command line tool in Linux to do the replacement. We're replacing this particular string, percent account ID percent, with the account ID, and then it's saying, okay, globally, throughout the entire document, we're going to place that. We'll replace this document, render this template into a file that will get those things replaced. We'll see. Now, we need this IoT policy.json file in there. So what you can do is that if you know how to use this command line tool to editor, then again, same thing that I've shown you before. You can use a vim to let's say IoT policy.json. I just copy the content and make a document like this. This is one way to do it. If you as you see, actually this the copy pasting doesn't work very well. So I'm not going to do this. I'm going to just upload instead. So this is the second way. Upload a file, select the file. So I'm going to actually copy path. Okay, open, upload. Now, when you're using Windows, it's going to be a little bit different in terms of finding the file in the File Explorer. So it'll be, I think you can figure that out. But the commands in the Cloud Shell is all the same. So okay, so that file is uploaded. It goes to the home folder. So it's actually one level up because we're actually under the W13 folder. And let's actually take that file, actually move that file here. Okay, let's do a move. So now we have this file right here, IoT policy.json. So if I do a cat, we'll see the content. This is the same file that I just explained to you. So we're gonna run this set command to do a replacement of the account ID. That's your account ID, which is gonna be different than mine. So we're gonna run this. And we'll generate another new file is .iot-policy. Now I use the dot because when you run this locally, this can be ignored. You do not need to check into Git repo, for example. So anyway, so you see this file has the account ID replaced. This is basically what this command does. So now we have this file, this we're going to use in the next command. Next command is to create a policy. So we're going to create a policy in AWS IoT, and we're going to reference that file here with this file : / the file name or path. And then it's the current path here, so it's going to be like that. The policy name will be just called this, CIS-30D-21S. So create a policy. Okay, so it tells me the policy is already created. Because I already have this, I can create a new policy if I want. But for, let's see, for your case, it's going to succeed. And so because I already have this created, so I'm showing you the creators, and I don't really need to create as the same thing. Now, the next thing I want to do is to find the certificate that we just created. So actually, let me take a look at this certificate. So I have two certificates. You're going to have one specifically. So it's kind of ordered based on the time, creation date. So I have a command that's going to grab the very first one. So the very first one is what we just created. We're going to get that certificate ARN. Basically, this is the value we want. So we're going to put that into a variable. So if you actually take a look at that, then you'll see this is exactly the value that I showed you that we want this value here. The certificate ARN is a JSON, and then we'll fetch that value through this JQ command. You see that? So, so we have the certificate ARN we're going to need to use in a later command. So the next thing I want to do is to attach a principal to the policy. So we attach the principal to a policy. So remember these policies that we just created, and then we have the certificate ARN as well. So we attach that principal, means it's basically the certificate is a principal. We attach that to the policy. And then we're also going to attach a principal, the same principal, to the thing. So we're going to attach thing principal. The thing name is that the thing that we created, and this is the certificate as the principal. So we're going to do that, right? And then once that's done, we have an endpoint that we can use to communicate. Okay, this endpoint, let me see. Okay, so it turns out if you have more things, like in my case, I have a thing 1 and thing 2, this endpoint is the same. So there is a MQTT broker is the endpoint. And this is the address you can use to communicate. Okay. Now, the way for the broker to identify which one is you is because you provide your certificate when you build your publisher or subscriber, and then that certificate identifies that particular thing, right? And the certificate is the principal. So, so this is the host. This is the broker host that you want to remember or copy it somewhere else. And then we're going to use this. And then let's take a look at the program. They're gonna, remember we have a version before we use the Mosquito broker. It's a free broker that's there for testing MQTT. So here, what AWS provides us, this endpoint is a MQTT compliant broker. So we actually can use this PAHO library to communicate with it. As I said, you can use AWS SDK. So they have an SDK you can use, and which is just a little bit more complicated than the PAHO we're already familiar with. So I'm gonna just choose to use that same library we used before to communicate with the AWS IoT. This is now, so this program here is pretty straightforward, and there's a little bit of difference. Let me explain. The thing name, so the thing name is basically the name, I call this thing2 now, all right? So the topic is, we use this course ID / that thing name as the topic. All right, we're gonna send a message to that topic for this thing2. So this is the message coming from thing2, which is, if we're gonna hook up our Raspberry, we're gonna run this Raspberry Pi, we'll have our physical circuit, and this Raspberry Pi unit with your modified circuit, it's basically a thing that, let's say that's the thing2, okay? In this example, I'm not connecting to that just yet, but you can certainly run this on the Pi or run on your host computer on your Windows if you want. It's the same thing, it's gonna run. But when we do get to run on the Pi is when we actually want to get data, actual data from the sensors. And we'll see in another example. So the broker host variable is that value that's output from here. Your value will be different from mine. And so you can just modify this to your value. Again, if we want to make this a little more generic, we can obviously use the .in file. So I didn't feel like it's necessary in this case. It's kind of fairly straightforward. We can, we'll probably use some of those later on. But anyway, you know the drill. There's different ways to do it. The broker port is, there's actually supports multiple different ports. We want to use a 443 here because that's some advantage in terms of the protocol negotiation, allows the our program to communicate with the broker in the most optimal way. So we're going to use this port 443. Let's take a look at the main function here. So same as before, create a client object from the PAHO cloud library. And then this client object, we're gonna actually do a little bit different than before, is we'll set up a TLS. Before we did not have any security. We communicated on an unsecured transport channel. So here we use TLS. And so with the TLS set of context, the context is an object from SSL library. So SSL library is part of the Python. Python has batteries included. That's what it really means. It's pretty much almost everything you need to use is there. So I have a couple of things to set up the SSL context into a different function here. And this function we're using, we'll set up have an object to SSL context. First, we'll set up the protocol to be a sort of a TLS for client side authentication. And then we're going to also, it does not specify the protocol version here because that protocol version will be negotiated with the broker. So we'll set the AOPN protocol. AOPN stands for, okay, what does it stand for? Stands for application layer protocol negotiation. So this allows the in this case, this program that we're going to run to publish message to a broker broker which is in AWS data center is the that communication. So initially it's going to communicate to negotiate the protocol version that both support, sort of the highest protocol version both will support that will be negotiated through the application layer. So it's ALPN allows you to do that. And the protocol has a specific string for this Amazon MQTT. So this is basically what the particular type of a protocol we're going to use. And then we're going to verify the location, verify locations. Basically, we're going to verify with the certificate authority, the Amazon root CA1 file that we downloaded from the Amazon Trust Services. So we're going to use that. Now this path variable here allows us to run the program, you know, in the same folder or with the full path, and it will be able to find these files that are sitting right next to it. Okay, so if we're assuming these certificate files are right next to this program, so this is just kind of a little convenience here. First, we get the path to this program through this statement here, and then we use that to make up the full path to the certificate files. This is what this is about. And then we're going to load the certificate from a certificate file. That's the one that we generated in the command before. And also we need to pass the private key file. So then we make up the SSL context, and then the program is ready to communicate on TLS. And so we'll pass that on to this client object. And then this is the same. We have a on connect handler. This will just print out some debugging messages here, really. It's not doing anything fancy. And then we're going to connect to the broker host and the broker port. And then we run a loop start. It's going to loop in the background thread. And then we're going to start publishing messages to the client. Well, with the client object here, using the client object to publish, basically use this publish method here on the client. And then here, we're going to actually publish a JSON message here, message with a number. The number increases every time this loop runs through. And this is the same as before. You see the slight modification. The main thing is about a TLS context setup, because it's a requirement to communicate with the AWS IoT securely, okay? So you can run this on your local host or on the Pi. If you run this on the Pi, you got to make sure you have these 3 files ready. So the files that we just generated here, these files, the .pem file, you want to just download those files. So what you do, you just basically do a download. So it's kind of a little primitive. It says download file to your local desktop. Folders are not supported. So what you have to do is basically download each of those files. Okay, so let me just kind of show you. I've already shown you this before. So let's say we're going to download one of those files. Let's say, and it's under the W13 folder. Let's say we want to download this thing to .cert.pem. Okay. And then you want to download the other files too, all the .pem files. So now you see, then you can say, well, save it to my downloads folder. Okay. So then you can put this right next to this program here, this MQTT publisher. And that's actually run this right here. Okay, so as you notice, it does not work The reason being, the thing2.cert file and the thing2 dash .prib file, these two files are not there. So I need to download those files. Let's see, priv.pem download. Okay. Now I'm going to move those two files into place, into the same folder as this file, this program here. I'm just going to move both of those PEM files to this folder here. Okay. So now I have those files moved over. Let's see if it's going to run. So now it's running. So we send a message, right? Each time is a JSON message called a message with a number to that topic, right? The topic is /thing2. Now, how do you know if this is working, right? This is working because it prints out these debugger messages and it's fine. And then let's actually take a look at the one thing here. Let's so open up IoT, go to the AWS console and search for IoT core. Click on IoT core. So first of all, I want to show you that if you look at the manage and the things, and then you'll see your thing defined here. So I have these two things here. You'll have thing2 if you follow this along. You can see there's actually different things here. You can see, for example, the security. This is the certificate we attach to this thing, the principal. Okay. But we want to see if this message is sent over, they're actually properly sent over, working or not. We're going to use this test. We're going to use this test client. So the test client, we're going to actually just use, actually, this is the topic. This thing2, subscribe. So it's very straightforward. And now you see suddenly this message show up. See, this is basically what we publish here into the broker. And this is, it's subscribed to it. And then now it's showing up here. Okay. And then this is all JSON messages. And then kind of AWS IoT assumes you want a JSON, just will be able to parse and understand the JSON. So this is saying your message going to the AWS IoT core is working just fine. Okay. So that's the publisher. And then you can actually write your own subscriber here. So I'm not going to go through this. This is, very much the same as before. I've explained this before. And then the difference is about the TLS setup, which is the same as what we just set up for the publisher. And so if you run this, change this to thing2, and this is your broker host. Then if you run this, it will basically print out this message just like what you see here with this test client. Okay, so now you can cancel this once you're done. You can even publish to a topic, to see if that is. So again, so this is just a test client, exactly like what we're doing here. And we'll write our own program because we're gonna need to incorporate with our sensors and the information from our device, send those actual information to AWS IoT. So this is what I want to show in this particular lecture, and there will be more features I'll add on to this in the lectures after this. That's it.